Welcome back to video 6 on conic sections. In this section, we're going to look at shifted conics. So far, we studied conics that have their center at the origin, but to be able to understand conics that are not positioned at the origin, think about the shifts of graphs. We've done transformations of graphs before, hopefully, in other classes. So if you have h and k, and they are both positive real numbers, then replacing x by x minus h, or by x plus h, and replacing y by y minus k, or by y plus k, we need to look at the following effects on the graph of any equation. If we replace x by x minus h, it's going to shift the graph to the right h units. If we replace x by x plus h, it will shift the graph to the left h units. Similarly, if we replace y by y minus k, it will shift the graph up k units. And if we replace y with y plus k, it will shift k downwards by k units. Now you might be wondering, why are the k's now behaving like the vertical shifts behaving like the horizontal shifts? That's never happened before. Well, remember that now the y minus k's and the y plus k's are going to be in parentheses, just like the x minus h's and the x plus h's are in parentheses. So now you're kind of like mentally setting them equal to 0 and solving for x and solving for y respectively, and that will change the sign of the h and the k. All right, now let's go ahead and try example 9. The tricky thing with these is to recognize which shape you have. Do you have a parabola? Do you have an ellipse? Do you have a hyperbola? And if you don't remember the formulas or the equations for each one, this is not going to be an easy task. If you recall, the sum of two fractions that have this form equaling 1 means you have an ellipse. And it's already been nicely finessed for us. And so now all we have to do is figure out the shifting. Notice that we don't have an x squared anymore, we have an x plus 1. And we don't have a y squared anymore, we have a y minus 3 squared. These are over 9 and 16 respectively, and so we can figure out what a and b will be. Since with an ellipse, a is always the larger denominator, we can say that a squared is equal to 16, which means a is equal to plus or minus 4. And that implies that b squared equals 9, so b is equal to plus or minus 3. The ellipse will be centered at a point, and we have to determine that based on these shifts. Since we have an x plus 1, it will be shifted to the left one, so we'll put a minus 1. And since we have a y minus 3 squared, that means that I will be shifted to the right 3. So the center of my ellipse will be at -1, 3. I can find the foci using the formula c squared equals a squared minus b squared. This will give me c squared equals 16 minus 9, which equals 7. So my c will be plus or minus the square root of 7, because remember, we need to solve for c, so we have to take the square root of both sides. This is approximately plus or minus 2.7, which means I have to take this value for my foci and combine it with where the center is. So if I know that my foci are going to be a vertical distance because my ellipse has a more vertical direction, the major axis is the y-axis instead of the x-axis, I'm going to take my value of 3 and then add or subtract 2.7. So 3 plus 2.7 will be 5.7. And 3 minus 2.7 will be 0.3. So these are my foci. And now I just need to figure out how tall this ellipse is going to be. I have an A that is plus or minus 4 and a B that is plus or minus 3. So I can count up from the center 4. So that will give me a 3 plus 4 is 7. And a 3 minus 4, which is negative 1. Now I just have to figure out how far to the left and right I need to count. That's found by using the B portion. So from negative 1 adding 3, I'll be at 2. And from negative 1 to negative 3 will be negative 4. And now I just connect my dots. So something close to that. Now let's look at the next example. We have x squared plus 6x plus 12y plus 9 equals 0. If we group this appropriately, or regroup it, however you want to say that, we'll have x squared plus 6x plus 9, and then plus 12y equals 0. Notice that I've grouped all my x terms with the 9, and I've kind of left this 12y off to the side. That is purposeful because I can factor the x squared plus 6x plus 9 to x plus 3 quantity squared plus 12y equals 0. That's convenient because now I can bring that 12y to the other side and it will look a heck of a lot like a parabola. I'll have x plus 3 squared is equal to negative 12y. The parabola has been shifted left 3 units. So let's just kind of unpack all this stuff. I have this negative 12, and that negative 12 is equal to 4p. If I divide both sides by 4, I'll just get p. That means p is negative 3. I also can calculate the focal diameter because focal diameter is equal to the absolute value of 4 times p, which is negative 3. And that gives me a 12. The focus is going to be at negative 3, negative 3. And you might be wondering, now how do I know that? Well, if you think about the fact that p is equal to negative 3, then I can deduce that this thing has been shifted to the left 3, and so from 0, I'm going to move to the left 3, and p is negative 3. So that means I go down 3 from there. If that's my focus, then I know that my directrix has to be at y equals positive 3. So this is just filling in all the little details. Now the focal diameter is 12, which means to the right and left of the focus, I'm going to count 6 units. from this -3 point. I'm going to count 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3, 4, 5, 6 to the left. And now I can just sketch my parabola. It's opening downwards and curving about the focus, and it is curving away from the directrix. The vertex, we could say, once we've sketched it, is -3, 0. In this last example, we have 16x squared minus 9y squared minus 96x plus 288 equals 0. We're going to have a really quick refresher on completing the square here so we can get it in the form of, I'm gonna say it's probably a hyperbola because we have a lot of negative signs. So let's go ahead and group these by their x's and y's. That's going to give me 16x squared minus 96x minus 9y squared plus 288 equals 0. I'm going to bring that 288 over to the other side. I'm also going to factor out a 16 out of these two terms here. That's going to give me an x squared minus, remember, 96 is 6 and 16. So I'm going to have a minus 6x as the second term. And I'm going to leave some space here because we need to complete the square. I also have a minus 9y squared equals negative 288. Now I'm going to add 9 inside, but that's equivalent to 16 times 9 because of that distribution rule. Remember, you can distribute inside parentheses. So 9 times 16 is actually equivalent to 144. Just put that in your memory banks, because if you're adding 144 to the left side, you also have to add 144 to the right-hand side. Now we have 16 times x squared minus 6x plus 9 minus 9y squared is equal to negative 144. This is now a perfect square trinomial, in which case I can write it as 16 times x plus minus x minus 3 quantity squared minus 9y squared equals negative 144. But I need that right-hand side to be equivalent to 1, and so I'm going to divide both sides by negative 144. Whatever I do to one side, I have to do to the other side. And now I'm going to rewrite. I have 16 over negative 144, and that's times x minus 3 quantity squared, minus 9y squared over negative 144 is equal to 1. It's getting closer. It almost looks like a hyperbola. We're almost there. This will reduce to negative x minus 3 quantity squared over 9. And the second one, the 9y squared over negative 144, is going to become a positive. Those negatives are going to simplify out. And 9 and 14 reduce. I just have a 16 in the denominator. So this becomes a plus y squared over 16. This equals 1. So now this is so close. I'm going to rearrange these terms so the leading term is positive. This will give me y squared over 16 minus x minus 3 quantity squared over 9 is equal to 1. Now that I have this in hyperbolic form, I can now write or sketch the hyperbola. Since the leading term is a y squared, this gives me a is equal to plus or minus 4. B is equal to plus or minus 3. And I can now sketch my center box. Since my y squared term is positive, I know that this is going to be a hyperbola opening upwards and downwards, so I can find the focus by finding C. C is going to be this plus or minus the square root of a squared plus b squared, which means I'll have C is equal to plus or minus the square root of 16 plus 9, which is equal to plus or minus the square root of 25, which is convenient because that gives me plus or minus 5. My focus will be at these 2 points, directly above the origin by 5 and directly below the origin by 5. I can now draw my diagonal asymptotes and extend them a ways. And now I just draw my hyperbola. Done.